Hi class! In today's lesson, you will learn about air pollution. So you learn different types of air pollutants, their sources, and the environmental and health consequences of these pollutants. And we will also discuss some of the ways in which we are improving our air quality. So first, a point source of pollution is one that you can trace to a discrete location, such as a factory, as opposed to non-point sources of pollution are ones where multiple inputs cumulatively together contribute to pollution. So you cannot trace the pollutants to any one specific thing. And an example of a non-point source are all of these cars, all the exhaust coming from the different cars. Now, both of these examples are human activities that increase air pollution. And when something is a human activity, we call that anthropogenic. So anthropogenic impacts on the environment are human activities that impact the environment. Now, there are also natural sources of air pollution, such as this dust storm that's rising over the Sahara Desert, or a forest fire, or volcano eruptions. Now, all of these are natural, but I wanted to ask you, can you think of human activities that can exacerbate these natural sources of pollution? Now, volcanoes, probably humans don't have much to do with that. But now think about forest fires and dust storms over deserts. Well, we have actually seen that climate change has been exacerbating these. As certain parts of the world are getting more hot and dry, scientists have observed the expansion of deserts. It's called desertification, and you'll learn more about that later. But as deserts are growing in size and expanding, we have seen more and more of these dust storms that are affecting the health of people living close by. And there's also been observations of increased numbers of forest fires and huge forest fires in recent years, again impacting our health. And now we'll go through some of the main types of air pollutants. Now, air pollutants can be separated into primary versus secondary pollutants. The primary pollutants are harmful substances that are emitted directly into the atmosphere, as opposed to secondary pollutants, which form when primary pollutants react either with each other or with components of the atmosphere, such as water vapor. Now, this slide, I'm going to summarize the main types of air pollutants, the most common ones. So in this line, we have the primary pollutants. Below, I will show you some of the secondary pollutants that result, and above, the sources that contribute to these pollutants. So our first one, PM, stands for particulate matter. Particulate matter, also called particulates, are any solid particles or liquid droplets that are small enough to stay suspended in the air. Their main sources are construction, forest fires, volcanoes, tobacco smoke, and others. Particulates can get into your respiratory system and aggravate it and sometimes even damage it. And the smaller the particulate, the more dangerous it is because it can get deeper into the lung tissue and damage the tissue. Our next pollutant is carbon monoxide. Carbon monoxide comes from the incomplete combustion of fuels. So anytime you're burning a fuel, whether it is wood, fire, gasoline, when it burns incompletely, it can produce carbon monoxide. Our biggest source of this pollutant is car exhaust, and it can be quite dangerous to leave your car running inside a closed garage with poor ventilation. Carbon monoxide gets into your blood and it impairs hemoglobin's ability to carry oxygen to your cells, so your cells die of lack of oxygen. Actually, I just heard on the radio a few days ago that a man who didn't have electricity for a few days had a generator on inside his garage, and the carbon monoxide from the garage got into the house and he unfortunately died. So be very aware of this. All right, our next pollutant is sulfur dioxide. Sulfur dioxide comes from burning coal and oil, primarily coal, also from smelting metals and some other industrial processes, and volcanoes are a natural source of sulfur dioxide. This molecule can also irritate the respiratory system, irritate the nose and the throat, and when it reacts with the atmosphere, it forms sulfuric acid. So this is sulfuric acid, which is formed when water vapor reacts with sulfur dioxide. And it's a component of acid rain, and we'll talk about the dangers of that in a little later. Okay, nitrogen oxide comes from primarily car exhaust and also from car burning. This one also irritates the respiratory system, can aggravate asthma and other breathing problems. And when it reacts with the atmosphere, it forms nitrogen dioxide and nitric acid. Nitric acid is another component of acid rain. Our next pollutant are VOCs, volatile organic compounds. This is a pretty big category of air pollutants. They can be various natural molecules that exist or formed from industrial processes. So industrial processes, car exhaust, and certain plants naturally emit volatile organic compounds. So these are organic molecules that can diffuse through the air. And these, depending on what they are, so many of the VOCs that result from industrial processes, they can cause cancer, immune system damage, even blood disorders. They can be quite dangerous. And when the VOCs react with nitrogen oxide in the atmosphere, they produce tropospheric ozone. This is the so-called bad ozone. We also have good ozone in our stratosphere, which protects us from damaging UV rays. This is not it. This is ozone present in the troposphere that forms from the reaction of nitrogen oxides and VOCs. And it is considered a pollutant. It can be very irritating to the eyes, nose, and throat. It can reduce your resistance to colds and pneumonia. So definitely bad for our health. And it is a component of photochemical smog, which I'll talk about in a moment. Our last main pollutant is lead. Lead can result from sources of lead are leaded gas and leaded paint and certain industrial processes such as making crystal glass. Lead is incredibly dangerous to human health. It can cause mental retardation, blindness, partial paralysis, and so there's been a big push to try to get rid of lead pollution. And so leaded gas, for example, is now banned in most countries, and leaded paint has also been phased out, but we still have some sources of it. Now, you've probably heard the term smog before, a word that was created out of smoke and fog. Now, there are two types of smog. The first one is called industrial smog, which is a combination of suspended particulate matter, sulfur dioxide, and droplets of sulfuric acid. The biggest source of industrial smog is burning coal. And here's a picture of London in 1952. Now, throughout its history, London has had big problems with industrial smog because of a lot of burning coal. In 1952, in December, there was a particular event when it was a very cold winter, and so people were burning coal for heat. And on top of that, in December, the conditions were, there was very little wind, so the air pollution was not dispersing and staying in London. And you can see during daytime just how dark it was. It was estimated that in the weeks after, that at least 4,000 people died of smog-related health problems. And more recent estimates say that as many as 12,000 might have died, and many more became ill. This 1952 air pollution event caused an environmental movement to really clean up the air pollution. Now, in these days, developed countries, the wealthier countries, really don't have much industrial smog anymore. But it is still a problem in the developing world where there isn't as good control over air pollution. So in China, it is known for its smog. Here's Beijing during the daytime. You can see how dark it is. And you might have heard on the news when the Beijing Olympics were taking place that this was discussed a lot about whether athletes would be able to stay healthy and actually compete in this pollution. And here's a satellite photo of the smog over China. It's a combination of industrial smog and also photochemical smog, which I'll talk about next. And you can distinguish it from clouds because the clouds appear as white, whereas the smog is gray. And they have measured the pollution from the smog making its way all across the Pacific Ocean to the western coast of the United States. Now, photochemical smog is also a big problem, and it's a problem in both developed and the developing world. Actually, even more so in the developed world. Photochemical, as the name suggests, a combination of chemicals, and photo means light. So the way it forms is from VOCs and nitrogen oxides. This NOx represents nitrogen oxide and nitrogen dioxide. So various nitrogen oxides reacting with VOCs in the presence of sunlight and heat to form tropospheric ozone and other secondary pollutants. So ozone and these other pollutants together are photochemical smog. And on the next slide, you can see also a picture of showing you that ozone and the nitrogen oxides coming from car exhaust and from factories reacting in the presence of sunlight to form ozone as well as other secondary pollutants. Car exhaust is the biggest source of these VOCs and nitrogen oxides. So where do you think you might have the most photochemical smog? Well, it's in cities such as Mexico City and also Los Angeles, where there's a lot of traffic, a lot of congestion, and these places have a lot of sunlight and heat. So together that creates the famous smog of Los Angeles and here Mexico City. Smog can sometimes get trapped in a city due to something called a temperature inversion. So let's take a look at what happens during that. So first, let's see what happens under normal conditions, not a temperature inversion. Under normal conditions, so here we have a land, and here's a town with its houses, and there might be a factory that's emitting some air pollution into the town. Usually, the air above the land is warm, and as you get further away from the land, you get cooler air. Warm air tends to rise, and as it rises, the air pollution gets dispersed. In temperature inversion, here's my land and here's the factory that's emitting pollutants. In a temperature inversion, a layer of cold air gets trapped beneath a layer of warm air. Cold air does not rise, so all of the pollution just stays in the town. And you can see that happening here in this picture as the smoke is rising and then it gets blocked. It cannot rise any further. These temperature inversions tend to happen in cities that are surrounded by mountains. At night, when it gets cold, you have the air next to the land is cool. Normally, during the daytime, sun would warm up the air and it can rise. But when there are mountains surrounding the town, the sunlight does not reach the areas close to the land as well. And so the air here stays cold while the air further up gets warmed up. And at that point, you have the cold air is trapped and it cannot rise. And plus the mountains are blocking wind from being able to disperse the air pollution. So Los Angeles tends to get a lot of these because it gets very cold there at night and then it gets warm during the day, but the mountains surrounding Los Angeles can contribute to the temperature inversion.